In this lesson, we will talk about sum of years digits method of depreciation. We also have solved problems at the end of the lesson. Let's get started. You bought an asset, a car, for $20,000. The car will be in use for 5 years and has a salvage value of $500. The first step in this approach is to find the depreciation base. In this example, the useful life of the asset is 5 years. We start with 1 and keep adding the consecutive numbers till the end of useful life. Depreciation base for this example is simply 1 plus 2 plus 3 plus 4 plus 5. 15 is the depreciation base. What happens if the useful life of the asset is 10 years? We have to add a lot of numbers until we reach 10. There is an easier way to add these numbers. Here is the formula. In this example, useful life is 5. 5 divided by 2 multiplied by 1 plus 5 gives us 15. It works. Next, we find the depreciable value, the value that has to be depreciated across the useful life of the asset. It is simply asset cost minus the salvage value. 20,000 minus 500, we have $19,500 as depreciable value. How do we split this depreciable value across the useful life of the asset? We have a base of 15. In the year 1, we use 5 out of 15. 5 by 15 of 19,500 is the depreciation in year 1. The number is $6,500. We should put a minus sign. Depreciation decreases the value of the asset. The asset value after 1 year is 20,000 minus 6,500 or $13,500. In second year, the depreciation is 4 by 15 of depreciable value or $19,500. That is $5,200. Asset value after 2 years is $8,300. We continue till we reach the 5th year. We consume the remaining depreciable value here. That is 1 by 15 of total depreciable value. The asset value after 5 years, the useful life, is $500, the salvage value. Finally, sum of years method belongs to a special category of depreciation techniques called accelerated depreciation. In sum of years method, the annual depreciation is much more in the initial years. It decreases with time. This is evident in our example too. Depreciation is $6,500 in year 1, but drops to $5,200 in year 2. It keeps decreasing across the lifetime of the asset. These characteristics are unique to accelerated depreciation. Double declining method also belongs to accelerated depreciation. This is unlike straight line depreciation, where the annual depreciation is constant across the useful life of the asset. We will look at a sample problem now. You bought a high-end computing machine for $1,700. You have decided to use the sum of years digits method for depreciation. The machine will be used for 5 years. The salvage value of the machine is $200. Which of the following is incorrect? A. The value of the computing machine after 5 years is $200. B. The value of depreciation in first year is $500. C. The depreciation in value will be more in initial years and will gradually decline over the useful life of the machine. D. The value of the computing machine after 2 years is $680. Please pause the video and try to find the correct choice. The problem provides us the asset acquisition cost of $1,700, useful life of 5 years, and salvage value of $200. Sum of years digits is used for depreciation. We have to identify the incorrect statement, not the correct statement. I hope you got that right. Let's look at the first choice. The value of the computing machine after 5 years is $200. 5 years is the useful life of the asset. After 5 years, we should be left with salvage value. $200 is the salvage value. So, A is correct. The next choice says that the value of depreciation in the first year is $500. Let's check that. First, the depreciable value, it is asset cost minus the salvage value, or $1,500. Sum of years digits is 1 plus 2 plus 3 plus 4 plus 5, or 15. So, the depreciation in year 1 will be 5 by 15 times $1,500, or $500. B is also a correct statement. C says that the depreciation in value will be more in initial years and will gradually decline over the useful life of the machine. This is definitely true for sum of years approach, an accelerated depreciation technique. C is also correct. We are only left with D. This has to be the incorrect statement and our answer. Still, we will have a look at this. The value of the computing machine after 2 years is $680. We have the depreciation for year 1. Let's do that for year 2 also. It is 4 by sum of years, or 4 by 15 times $1,500, or $400. The asset value after 2 years will be initial value of $1,700 minus $500, depreciation in year 1 minus $400, depreciation in year 2, or $800. D says $680, which is incorrect. D is our choice.